So today we'll be talking about a new data type called sets. Okay. Now let us see how these sets, what are these sets and how it is used and why it is used. Okay. So sets are something. Sets are a special data type which can store unique values. So if we remember, let us go back to our we had one documentation, right? Let's see. Data types, huh? So what was written here about sets? So set types, they are saying there are two types. Okay, fine. But what is it saying? An unordered collection of unique items. What is the meaning? An unordered collection of unique items. See, in lists, what we are having is list is an ordered mutable collection of items. It is an ordered collection of items, but sets are unordered. How we can say that lists are ordered? At zero index, one value is there. Always zero index, that value will be there, right? Let's say I have a list nums equal to 2 comma 12 comma 4 comma 5 comma 27. Now if I check today, print nums of 0, what I will get? 2. I will get 2, right? But if I come tomorrow again and again I check this nums of 0, what I will get? 2, right? So if I don't change the array, so if I don't change the list, am I changing the list? No, I'm not modifying the list. I'm not touching the list. But what I'm doing is I'm trying to access this nums of 0. So today also I'll get 0. Tomorrow also I'll get 0. Day after tomorrow also I'll get 0, right? But that is not the case with. So what is happening? Each element is having a fixed index, right? Order is same. After 2, always 12 will be there. If I change it, that is different. But if I don't change it, after 2, always 12 will be there. After 12, always 4 will be there. After 4, always 5 will be there. And after 5, always 27 will be there, right? So that's why a list is known as uh, an ordered collection of items. Okay, an ordered collection of items, allowing duplicates also. Duplicate numbers can be there. I can have 27 comma 2. It is not wrong, right? It is correct. Okay, so that ordered and allowing duplicates, this is where the difference is there with the list and set. First thing is it is not ordered, it is unordered. That means now if I do print terms of 0, I may get 2. After some time I may get 4 also. Okay, so that is what set is, not lists. This is a list, this is not set. We'll see how the set is looking like, how the set will look like, we'll see that. But sets, what is happening? The order is not fixed, it is random, it is always moving here and there. Okay, that is one thing. Next, it is saying that it is a collection of unique items. That means it will not allow duplicates. It will never have duplicate items. If I put duplicate also, it will remove it automatically. Only unique items will be there. So now if I try to print this nums, what is happening? Sorry, the sets py sets.py. So I'm getting a list containing all the numbers including duplicate. See, duplicate number is there. So this is allowed in lists, but this is not allowed in sets. In sets, I can put duplicate number like this, no problem. But in the output, I will not get this 2. I'll get only up to 27. Okay. Those are the two main things you should know about a set. Then there are different things like some things may be mutable, something may be immutable. That is different. That we'll see when we study the different types of set. Okay. So the first thing that we should know is that it is an unordered collection of unique items. So first let us see how to create a set, right? So and also we should not forget our documentation. We should not miss any topic from there. Whatever course curriculum we have here, we should not miss any topic. Okay. Okay, fine. So we know what is a set now. We know that there are two types of sets, set and frozen set, but we'll see that later on. Now no need to worry about that. And importance of set data type. So what is the importance of, why do we need set data types? Because the main purpose of using set is to remove duplicates. Okay, sets are used to remove the duplicates, because list is not allowing that. List is allowing all duplicates to be present in the list, but set, when we use set, automatically duplicates get removed. Now let us see how to create a set using the literal. Okay, so here we write something like this: nums or anything, yeah, nums is equal to, we put curly brace like this, and then I put the values 21, 2, 34, 5. If I now print this nums, okay, this is what I'm getting. Okay, now when I'm printing it again, see, I'm getting the same order, but it is not fixed. Okay, you may get something else as well. If I try to put a string here, see what is happening? It is changing. Okay, so we can see that. So let's say it is a set of strings. Hi, hello, apple. What will happen now? We can see that all the positions are changing, right? So it is, that's why it is said that it is not an ordered list, it is an unordered list, unordered collection. Here it is written, it is an unordered collection. Okay, that is first meaning. Second thing is unique items. Let us see now. Let me put one more high here. What will happen now? Am I getting too high? No, automatically one of the high is removed. Okay, it is removing one of the high. So we can have lot of duplicates here. Hi, hello, apple, mango, whatever. All duplicates will be removed. Only one type of data will be there. But if I put a number, what happens is, even the number is now changing. See, number position is also changing. Okay. So actually the string values are changing. That's why we are seeing that the number is also changing. Okay. So this way what we can say is that a set values, our first thing is unordered, there is no order, and second thing is they are unique. They will never hold any duplicate values. Okay, that is the definition. Okay, next what is there? So now this is known as literal. Whenever you're using this equal to and putting like this, it is known as a set literal. Okay, but we can create set using this set function also. Okay, let us see how do we create. X is equal to set of 1 comma 2 comma 3. So now what will happen? It will create a set containing 1 2 3. What we are using explicit typecasting. Okay, so let us see whether this will work or not, because there are a lot of things. Print X, it may give us an error. Now let us see, is it giving error? Yes. So it is saying it is asking for only one argument. So what I can do is I can pass a list. Okay, I'll pass a list. Now everything will be fine. So now what we are doing, we are converting a list into set. We can get the set here. Okay, this is how we can create a set using typecasting as well. Okay. Now this is a normal set. We have another set called frozen set. So let us see what is that frozen set. What is the definition? An immutable set. Okay. So for that, first we have to know whether we can mutate this set or not. Okay. Let us see that. First thing is we will try to change the value of a set. Nums is equal to 2, 5, 7. Okay. So print nums of 0. Is it allowing? Is it giving me some value? It is saying no. It is not giving us the value at index 0. Why? Because we know that it will keep on changing. So at 0 we will get different value. That's why they don't support indexing. That means indexing is not supported in set directory, right? So then how do we mutate? So for mutation we have some methods. We have add, remove and all those things. We will see that after some time, but just for showing you, I will show something like this. Nums dot add of let's say 4. Now what will happen? We'll get the 7 value as well. So here we can see that it is mutable, right? It is not immutable. We are able to add new values, so it is mutable. Okay, but when I create a frozen set, it is immutable. Now frozen set we cannot create like using literal. Okay, we cannot create frozen set using literal. How do we create? We have to always write frozen set of one list, let's say. Okay, I have to create it like this. Print C. So this is the way to create a frozen set. It will look like this. Frozen set of this. Now I cannot change any values here. Let me try to do that. What did I do earlier? C dot add, right? I was trying to add another number. Let's say 6. So what will happen now? It will not allow. Frozen set has no attribute add. So add, remove, all these things are not allowed on the frozen set because it is immutable. By using frozen set, we are creating an immutable set. Okay. So that is the difference between set and frozen set. Okay. Let us see now. Next. So here we are able to create a set using set and frozen set functions. Both we have seen, right? Now there is a concept called empty set. How do we create one empty set? Now see here. How do we create empty list? Normally list is like this, right? Empty list means how I will create empty, empty list. It should not contain what are the values it is containing? Some values are there. I don't want any numbers. Then how do I create? I create an empty list like this. Okay, it is an empty list. So empty tuple like this. So let me show you from beginning. So this is an empty list, and if I print the C and print the type of C, what I will get? Here I will get empty list. Here I will get list, class list, right? See this, empty list and class list. Same thing I will do with tuples. List tuple. So list string also, empty string is like this. So here what I will get? Empty, actually empty is not coming. It is coming here, but we are getting that empty string and class is string. In the same way, tuple also I'll do it same like that. Correct? Then what about set? In set, what we are using? Flower bracket. But what will happen? It is an empty dictionary. Okay, it is not saying that it is an empty set because we already know that flower bracket is used in dictionaries. So that's why Python is not able to understand that this is a set. But if I write 1 comma 2 comma 3, now the same code will give me set. But if I don't put any values here, it is saying it is dictionary. Okay. If I write here name colon Hari, I'll get dictionary. Okay. But instead of key value pair, if I put 1 comma 2 comma 3, I'll get set. But when I empty everything, nothing is there, then I get it is a dictionary, because it is thinking that it is a dictionary. It is not thinking that it is a set. Then how do I create an empty set? So for that, we have to do something like this. We have to use this. Okay, this is the only way to create an empty set. Okay, now let's see. Here we are creating an empty set. Okay, it is giving like this, something like this, and it is saying that it is an set, right? Okay, this is how we can create empty set. Fine, because empty set may be needed sometimes, because after creating this I want to add some value. C dot add of 23. So what will happen? I'll get 23 now in the set. Okay, so empty set may be needed sometimes. Okay, next, removal of duplicate elements in set. Now let us see what happens. Let me create a set first. Let me create a set of numbers 23, 56, 34, 1, 8, 9, 56, 1, 23. So what is the output I should get? Right? Okay, let me remove this 9. Okay, 9 comma. So I will not get 56, 1 and 23 in the output. Okay, correct. These three numbers I'm not getting. Remaining I'm getting all 23. See now, are they in order? No, they're not in order. So it is showing that it is unordered collection, and also it is having unique values. It is able to remove the duplicates automatically. Okay, so there was a question where we had removing duplicates from a list, right? So let me have a list. Nums equal to 12, 21. Okay, 12, 56, 3, 7, 21, 3, 67, 12, right? I want to remove the duplicates. I can use for loop to do some checking and remove the duplicates. I can take another list where I will put all the numbers, only unique numbers. So that is possible, but if you want to do it in one line or very in a very compact way, what I can do is I'll create one new nums1. Nums1 is equal to set of nums. Okay, so in one line that is over. No need to do anything. Now I'll print the nums1. In the nums1 I can see this, right? But what do you want? If you want to create a list of it, I want a list which does not contain the duplicates. So again I will convert it back to list of set of nums. First the nums is converted to set, then the set is converted to list. Now I can see I have, oh, what happened? List of, oh, I didn't save it, sorry. Now see, what did I get? I got a list and only unique values, right? This is how we can create a list of unique values. That means we can remove the duplicates. Okay, and one thing we cannot avoid here is the order. Okay, see, order has changed, order of the numbers has changed, so that is not easily possible. Okay, it will be difficult, but even then our main question is to remove the duplicates only, right? So that is done, right? This is how we can remove duplicates. Okay, fine. Next, membership testing. Okay. So before going into this membership testing, let us see something more. Okay. So this set data type. Okay. So I wanted to show you about strings, but that will be possible only in the membership testing. Okay. So no problem. Let us see. So we have a set v. V is equal to, or values is equal to one set which contains some. Okay. Huh. Now I will do the membership testing. Print 3 in values. What I will get? True. 3 is there or not? 3 not in values. False. 9 not in values. True. 9 in values. False. Okay. So the membership testing is working totally fine. Fine. Okay. Now let's see. Now the length function. Okay. What is happening in the length? So print length of values. So what is the length of values? Sorry? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But we should not get 11 because duplicates will be removed. No? The moment I am using this curly brace, what will happen? It will remove the duplicate. So 1, 5, 6, 3, 45 and 24. 1, 2, 3, 4, 5, 6, 7. And 4. So 2, 3, 4, 4. 2 is also there. These are the unique values. Yes or no? 1, 5, 6, 3, 45, 23, 4 and 2. Correct? 3, 4, 4 will not be included, right? So 1, 2, 3, 4, 5, 6, 7, 8. So length should be 8, right? This is how the length function is working in sets. It will calculate the values only after removing the duplicate, not before removing the duplicate. Okay. So the set length will reduce if there are duplicate values. Okay, fine. Next, looping in sets. Okay, let us see looping is supported or not. So for v in values, print v. Is it working fine? But order, see, it is totally mixed. I'll run it again. Again, I'm getting same order. Okay. So every time I'm getting same order, but it may not be same all the time. This printing order is same, but is it taking the same order from here? No. Okay. So that way the things will be different. But from here, what is our agenda is we are able to see that looping is supported in sets. Okay. For loop I can use in the same way. I can use I think while loop it will be difficult. While loop will not work maybe because we don't have the index here. Okay, so while loop will not work. So for loop will be used for this kind of data type. Okay. Next, because there is no index, so enumerate function will also be useless here. Okay, fine. Next, now we have 4 very important topics. Okay, this will take some time. Okay, it may go more than half an hour also, but we have to see these things very carefully. Set operation, set comparison, And then we have some topic called superset, subset, and disjoint, and then we'll go on to set methods. Okay, so first we'll see the set operations. What kind of set operations we have in Python? So there are basically maybe more methods, operation will be there, but mostly we need four operations. Okay, the four operations are: first one is known as union, then something is called intersection, then there is a difference, and then we have something called symmetric difference. How many are there? Four: union, intersection, difference, and symmetric difference. We have to understand them. Okay, now before going into that, we have to know what is a set theoretically. Here what we are doing, we know that only it will have unique value, so we will use it for removing duplicate. Okay, but in reality set has lot of things. Okay, so first let me take two sets. Now these are set operations. So set operation means what? We need operators. Okay, so when we have numbers, what kind of operation we are doing? Arithmetic, like addition, subtraction. So for addition, how many numbers I need? One number is enough? At least two numbers is needed, right? At least two numbers are needed to do some operation. In the same way, to do set operation, how many sets I need minimum? At least two set. With one set I cannot do anything, right? So let me take two sets, 1 comma 2 comma 3. Let me take comma 4 as well, and b is equal to 3 comma 4 comma 5 comma 6. Okay, now see, now I am using a set. After some time I may use a string also, so I'll show you that thing after some time, but let us first understand this one. Okay, so here, mm, first we will go with this kind of things, union and intersection. But first here you see that a set is a collection of elements, unique elements. Even if I put one more 4 here, there is no use. Okay, Python will automatically remove that 4, so better not to use that. It is of no use, right? So I'm having two sets here, and I want to operate, do some operations. But what is the meaning of these operations? We'll not simply do any plus, minus, and all those things. We should know what, why we are doing this and what we want to do. So first operation, what is the first operation? Union. Okay, so what is the meaning of union? Is that it is a combined collection of all the elements. Okay, it may be present in, so when I'm asking A union B, we don't write it like this. I'm just writing A union B. That means the characters or the elements present in A or B or both. Tell me a number which is present in A or B. That is present in both. 1 2 3 4 5 6 is present in A or B. Huh? So so the meaning of this A union B is that, the meaning of A union B is that elements present in A or B or both. Okay. Okay. Now see, A or B means which numbers? 1 2 3 4 5 6. They are present in A or B. What about both? Present in both. 3 4, right? So I'm asking for elements which are present in A or B or both. So that means all the numbers 1 2 3 4 5 6 are the numbers if we try to do union. Okay, so now let us see how do we do the union operation. For union operation we write something like this. So C is equal to, so we write A B and then C equal to A plus B, right? So here I'll write A, this symbol, and B. This is the meaning of that is the operator used for union. Okay, union means the numbers present in A or B or both. Actually, that means it is the combination of all numbers. Okay, and it will remove the duplicates. So if I combine all the numbers, what I will get? 1 2 3 4 3 4 5 6. Then 3 4 will be removed because unique elements, right? So now I'll print the C. What I should get? 1 2 3 4 5 6. Let's see now. Did I get 1 2 3 4 5 6? Yes. So C is now a new set. C is a new set where all the numbers are present. Okay, fine. Now this is known as union. Next topic is intersection. Now let us see what is the meaning of intersection. A intersection B. This means elements present in both A and B. What is the meaning? Elements present in both A and B. Is 1 present in both A and B? Is 2 present in both A and B? Is 3 present in both A and B? Is 4 present in both A and B? So what will be the intersection of A and B? 3 and 4 only. Okay. So the symbol for intersection is AND. Okay. What I am asking? Elements present in A and B. This meaning is OR. A or B. Okay. This meaning is AND. Present in both A and B. So what I should get? 3 and 4 only. Let us see now. Am I getting it? Yes. This is about intersection. Okay. Now this union and intersection, there is no order here. That means I can write A or B. Then also I am getting 1 2 3 4 5 6. If I write B or A, then also I'll get same. I'm asking present in B or A, isn't it? In the same way, this intersection is also same. A and B, present in A and B is giving me 3 and 4. Present in B and A is also meaning the same meaning, right? Both B and A. So that's why we are getting same kind of output. Now we are moving on to the next topic, which is the next operation, which is difference. Okay. Now see, the symbol for difference is minus. When I write A minus B, the meaning is elements present in A but not in B. So here I'll write A difference B. What is the meaning? Present in A but not in B. Present in A but not in B. 1 and 2. Right? Correct? But if I write B minus A, what will happen? Present in B but not in A. 5 6. Right? So here the order is important. In difference, we have to think about it. When we are giving A minus B, it says that present in A but not in B. When I write B minus A, it is present in B but not in A. Okay, so here the order will be mattering. When it is union and intersection, there is no matter, but here it is matter. Okay, next. Now, present in A but not in B. Okay, fine. That is fine. Now, there is the last topic, that is symmetric difference. Okay, so what is this symmetric difference? A, I'll write SD. Okay, symmetric difference. S diff. Symmetric difference. Just I'm writing. So it's A symmetric difference B. What is the meaning? Elements present in A or B but not both. Present in A or B but not in both. Which numbers? Present in A or B. A or B means present in A or B. 1, 2, 3, 4, 5. But not in both. 3, 4. So present in A or B, but it should not be present in both. Which numbers are present in both? So they will not be allowed. Only present in A or B, but not common. So which numbers? 1, 2, 5, 6. Right? So let us see. The symbol for this is this symbol. Okay. So first I will write A cap B, and let us now see the output. 1, 2, 5, 6. But if I do this, I think we will get the same. Present in B or A both, but not in both. B or A, but not in both. Again, I get 1, 2, 5. So only difference. In difference, we have to see the order A or B, B or A. That A minus B, B minus A will be different. But in these three methods, that A, B order doesn't matter. Okay. And symmetric difference, what it is giving us? It is giving us present in A or B, but not in both. Okay. These are some of the operations, or we can say that these are some of the set operations, which are very important. Now the set operations can be applied on strings as well. Okay, let us see now. Hi and hello. First, I'll start with union. A or B. What is the meaning of union? Elements present in A or B or both. So what output I should get? Why hi? How hi hello I'll get? Duplicate, how you will get? We used 1, 2, 3, 4, 5, 6, 7, 8. Characters. In set A, what is there? Earlier in this set, how many values were there? 4. Now I'm considering this as set, then how many values are there? No, 2, age and I. So in second set, how many values are there? 5. Now tell me A or B. What is the meaning of A or B? Elements present in A or B or both. Don't say hi, one character. You are saying 12 or what? 1, 2, na? How ELL? So no duplicates. So I should get HIELO. Oh, what happened? Okay. So there is a problem here. Why I am not able to do this? So for that, I need to use the what it is called. Let me do this. I'll show you how to do that, but for the time being, I'll do it like this. I'm converting the string into set, okay? Because string, how can we apply that thing? Set of A and set of B. Now it is fine. Okay. Now what I should get? H E HIELO. Am I getting those characters? Order will not be same, but we're getting it right. Next, what we'll try? Intersection. What is the meaning of intersection? Present in both A and B. Which are the elements present in both A and B? Only H, right? So what I will get? Only H. Correct? Next, difference. Present in A but not in B. Which one? I. Present in A but not in B. Let us try the reverse one. Present in B but not in A. ELO. Correct? Next, the symmetric difference. Present in A or B but not in both. IELO. H will not be there because H is present in both. Right? So we'll get IELO. Correct? So these two things we have seen. But when we have to remember one thing, that when we are using string, we have to convert it to set like this. Only then it will work. Okay. For that also I have a solution. In Python there is a solution for that also. But let me check that thing. set comparison is there. Okay. Okay, no problem. I'll show you that thing first. So that topic is not listed here. So for that, we have some methods, okay, which we can apply directly. Okay. Let me check what were those methods. Okay, fine. I can do it now. So when I'm using these symbols, problem with this symbol is that if I use this symbol, this thing must be a set. If it is not set, if it is a string, it will not work. If it is a string, I have to convert it into set and then it will work, right? Ah. So what Python has given us is that there is a method now. First, I will do union. So a dot union of b. So when I do this, it will automatically convert this a and b into set. Okay, no need to convert it. So now if I check, what happened? str object has no attribute. Okay. So here also some problems are there. So there is no way. So I have to do it like this. So using this union, so for this union, what symbol we are using? This symbol. Or I can go with union method. Okay. But the plus point of union method is that this b, I don't need to convert to set. But this a needs to be converted. That is mandatory. Okay. Now see. Now it will work. Now it is working. Okay. The first value I have to convert it to set. The second one your wish. Okay. Then next. For union we are getting, so set of b dot union of a will also give us same value, right? IOHEL, right? Then intersection. So intersection also we have a method called intersection like this. B dot intersection of a. What is the meaning? Elements present in both a and b. Which number? Which h only, right? Next we have difference. Set b dot difference of a. What is the meaning? Present in b but not in a. ELO, right? Present in a but not in b. I only. Correct? Then we have the lastly symmetric difference. Now the method spelling is C. Symmetric underscore difference. Okay, symmetric underscore difference. I have to write like this. Okay, what is the meaning? Present in A or B but not in both. How H? Present in A or B but not both. IELO. Right? So the symbols and these methods are doing the same thing, but we should know how to do it in different ways. Okay, when I'm using symbols, what is happening? I have to convert both the string into set first, only then it will work. But when I'm using these methods, only the first value needs to be converted. Now see, these things are not for strings. I can use it for set also. Okay, let me use a set 1 comma 2 comma 3 comma 4, and what I was using here 3 comma 4 comma 5 comma 6. Now I don't need to use this set of a. Directly I can do a dot symmetric difference of b. So I'll get 1 2 5 6. A dot union of b. 1 2 3 4 5 6. A dot intersection of b. Get 3 and 4. Okay, so these methods and the symbols are working totally same way, but the only difference is in symbols will only support sets. If it is not set, we have to convert to set, then we will use. Okay, but when we are using these methods, it will accept set as well as not set non-set values, but the first value must be converted to set. Second value it will automatically convert. Okay, so this is about what it is called set operations. Okay, now Now the next topic that we have is set comparison. Okay, set comparison means how do we compare two numbers? Greater than, less than, isn't it? Same thing we'll try to do here. So I have these two sets. Okay, I have these two sets. Now what I'll try to do, first I'll compare, print a double equal to b. What am I trying to ask? I'm asking that these two sets are equal or not. Is it equal? No. So I should get false. What about 1 2 3 4 and 1 2 3 4? True. What about 3 comma 4 comma 1 comma 2? This is also true, right? This should also be true, because we know in set there is no order, isn't it? Even if the order is not there, it will check the elements and it is giving us equal. It is true, right? Now this is about equality. Now I'll go for something else. So if I have 1 2 3 4 5 6, it will always be false. It's not equal, isn't it? Now, but I will do something different. I will now try to check a less than b. Is a less than b? What is the meaning of a less than b? That we have to know here. So it is asking that is a part of b? A is a part of b, right? So a is actually a small part of the big set b. A is a small set, b is a big set. Now a is a small set which is a part of the big set b, right? So it should give us true. Yes. What about 1 comma 2 comma 6 comma 4? 1 to 6 4 is a part of b or not? True. Yes. So this will also give us true. What about only one? True. What about 1 comma 2 comma 3 comma 4 comma 5 comma 6? Is that thing also a part of? So this is also true. Oh, what is saying? It is saying false, right? So that means this is not a part of this set. Okay. Fine. Now let us come. I'll come to that point why when that will happen. But first let us see understand what was happening till now. So whenever a set is a part of another set, this small set, so that means one of them is small, right? So this set is known as a subset. It is a subset of b. Okay, and this is known as superset of a. Okay, subset and superset is the concept that we need when we are comparing two sets using less than greater than. Okay, now if I type here b greater than a, is it true? B greater than a, true, isn't it? If I have here now b is not greater than a. Okay, so b is not a superset of a now. Okay, so that is about superset subset. Okay, so when we say, now let us come back to this point. Here according to mathematics, when we learn in college and school about sets, there we have seen that we actually say that this is a subset of this. When two sets are equal, we say that a is a subset of b, and we can also say that a is a superset of b also. Actually they should be equal. Okay, actually they should support that it is a subset of a. So for that what we do is, we don't, if we do this we are getting false, because that is actually false, but we should actually do this. This is how we check whether b is a subset of a or not. To check subset, to check whether another one set is a subset of another or not, we should not use less than, we should use less than equal to. Okay, now we are getting true. Okay, fine. So that is about the comparisons. Now for these comparisons also there are some methods. Maybe let me check once. Yes, there are three methods, okay, to do that. Either we can do using these symbols, or else I can use something like this. So I'll write a dot is subset, sorry, is small letter all, is subset of b. So I'm asking, is a subset of b? Yes. Is a subset of b? Yes. Is a subset of b? No. Is a subset of b? No, because now the a is actually a superset, right? Now we will set. Now we will check the superset. Is superset of b. Is a superset of b? Yes, it is true. Is a superset of b? Yes, this is also supported. Is a superset of b? No, will get false. Okay, so this is how these two methods will work. Now there is another thing which is known as disjoint. What is the meaning of disjoint? Set disjoint. A pair of set which does not have any common element are called disjoint sets. See these two sets? Any common elements are there? No. So they are known as disjoint. X is a disjoint of Y. Y is a disjoint of X. Okay. So here I will write is disjoint. So can I say A is a disjoint of B? No, because there are common elements, right? If common elements are not there, only then I can say that it is a disjoint. So if I write here 1 comma 9 comma 8, 1 comma 9 comma 8, is A is a disjoint of B? No, still one common is there, right? But the moment I write here 7, is A a disjoint of B? Yes, there are no common elements, right? So there one more point is there. Okay, whenever I am doing an intersection, what was the meaning of intersection? Intersection means characters in elements in both A and B. Okay, so let me do print A dot intersection of B, right? What it is giving? Empty set. Whenever the intersection of two sets is empty set, we can say that they both are disjoint. Okay, see, I have here 1 7 9 8 1. What is the intersection? What is common? 1. So I will get 1. Okay, but if the intersection is giving empty set, only then I can say it is a disjoint. Okay, so what I should check is, when we are checking the intersection of two set, if the length of the intersection is 0, we can say that they are disjoint. What is the length of this intersection? Length is 1. Only one element is there. If I put here 7 9 comma 3 comma 8 comma 1, what will be the intersection? 3 and 1. What is the length? 2. Length will be 2. If the length is 2, it is not disjoint. If the length is 0, only then it is disjoint. So when I have this situation, what is the intersection? Intersection. What is the intersection? Empty set. Empty set. So the length is 0. If the length is 0, it is a disjoint. So that is the relation between intersection and disjoint. Okay, that we have to keep in mind. Okay, fine. Now what is left. So these three things are very important. Okay, these three things, and even this set method is also important. These four things actually. Okay, apart from removing duplicate, these are the four things which are very important in case of set. Okay, so when someone is asking you why sets are used, don't say that it is only for removing duplicates, but lot of other operations are also supported, which are not supported in. If we have a list, if I want to, I have two lists, I want to know which are the common elements, I don't have any method, I have to do so many looping. Okay, so instead of that, I can convert the two list into set, then do the superset subset disjoint, and then we can convert it back to list and give the output. Okay, now let's see the set methods. Now there are 5 set methods. Okay, let us see. So first I'll take one basic set. First is adding elements. So a dot add of some number 34, let's say, and I print the a, print the a. So what will happen in the set? 8, 9, 34 and 7 are there, right? We are able to add a value. Now after adding, we can have a so pop method. To remember pop method in list, it removes the last element, but here what will happen is the last element is not fixed, the order is not fixed, right? So sometimes it may remove some random element also. Now it is number, that's why we are getting this kind of thing. But let's say I have a hi, hello and welcome. Now let us see what will happen with the pop. Now which one is removed? Hi is removed. Now okay. Now now hmm. So pop will remove one random element from the set. Okay. So that is add, we have seen that, in we have seen pop. Okay, but there are some more things. There is something called discard. Okay, now this discard will not work like this. It will ask which one you want to remove. Pop, what it is doing, it is removing a random one. But discard is not like that. We have to tell which one you want to remove. Which one you want to remove? Tell me. High. Okay, I'll put the high here. Now once it removes the high, we will have hello and welcome. So this will always give same output, it will not give different output, because we know what we were removing. We are removing only one thing. Okay, that is the difference between pop and discard. Now we have another one called remove. Let us see what is that remove. If I don't pass anything, exactly takes one value. Okay, let me check. High I will remove, working in the same way. Then what is the difference? That means there is no difference between discard and remove. But there is a difference. Now we will see. Let us go back to the discard method once again. So now I am discarding hi. So what will be the output? Hello, welcome, or maybe welcome, hello, right? Now let me try to remove something which is not there. Good. Is good there in the set? No, it is not there, but I am trying to remove. Okay, let me check what it is giving. So if it is not there, then also discard is not doing anything. So hi, hello, welcome is there. Fine. Same thing if I try with remove, we'll see that it is giving key error good. Good is not there. That is the difference between discard and remove. Okay. Discard is allowing unknown values also, but remove is asking only for values that are present there. Okay. Next. Next, we have one more method that is known as clear. A dot clear. What will happen? Clear means all clear. So it will delete everything. So now we have empty set. to empty one set. So let's say we have one set, we are putting values, and after some time I want to empty it, I want to put new values. Then what I will do, clear it, and then I will put new values. Okay. So this is all about sets. Okay, so this last four parts are very, very important. Okay, here, apart from that, now this frozen set is not supporting so many things, because frozen set is not supporting this set method, because that is immutable. I cannot add, remove, delete anything. Okay, so the set methods are not supported, but union, intersection, everything is supported, because we are not modifying the set, we are creating new set using union, intersection. After union, we are creating a new set which contains all the elements, right? That way. So this is all about sets. Okay, that's it for this session, and see you with the next new topic in the next class.